Hey guys, it's Jeff. Today I'm going to be reviewing a book and discussing a book called Parallel Worlds by Michio Kaku. If you don't know who Michio Kaku is, there's a photo of him on the back there. And he's a pretty popular physicist, string theorist, who's appeared on, numerous science TV shows. They'll interview him about certain topics. He wrote a book called Parallel Worlds, and it came out in 2005, and it's about 361 pages long, so it's a pretty good length. And it's discussing the possibility of alternate universes existing, so that our universe is not the only one, but one of many that all exist within a multiverse, which is, if you can imagine, like soap bubbles all existing together, kind of just around each other, that even though we can't necessarily interact with other universes, but ours would exist as one bubble in many. And since this is a nonfiction book, it's not a novel, it's a nonfiction, there's a lot of science in here. And there's so much information that I don't think I could possibly cover everything that's in here. So what I thought I'd do is kind of just go through the table of contents and kind of just read off the different sections of the book and then kind of offer comments about, just kind of what the book offers. So it's divided into three parts. The first part is the universe. Chapter 1, Baby Pictures of the Universe. He discusses the cosmic microwave background, which is basically like they call it the baby picture of the universe. It's the earliest photo that they can take of the universe, because that's when light particles started to settle. Because at the beginning of the universe, it was so hot and so chaotic that particles were basically becoming each other and nothing was stable enough to stay together. Like protons would become electrons and neutrons, and it was all like one big soupy mess, and nothing was staying together as a proton, as an electron. As soon as they came into existence, they crashed with another particle and became something else. So the cosmic microwave background is something that was 380,000 years ago. So they're basically taking a photo of what the universe looked like 380,000 years after its creation, or after it came into existence, which is pretty cool, how they're able to do that. I don't think there's a photo of it in this book, but if you just Google cosmic microwave background, you'll be able to find that. So that was really interesting. The paradoxical universe is chapter 2. Chapter 3, the Big Bang, just discussing just different theories of how the universe could have come into existence, whether it actually came from nothing, whether it came from a singularity that just existed forever and inflated. One theory of how the universe came into existence is inflation, where rather than something just exploding, it inflated like a balloon. So if you were to draw galaxies and stars and stuff on a balloon and blow it up, then you would see all of those galaxies expanding away from each other, because the main reason why they thought that the universe began that way is because it is expanding, and not only expanding, but accelerating away from wherever you look in the sky, you can see galaxies and stars and planets all moving away from you. So they figured, well, if everything is moving away, then if we reverse the clock, then everything must have at some point gone so far back that everything was into a single point. Everything in the universe was condensed down into a singularity. So chapter 4 is inflation and parallel universes. There's a lot of science that went into why he thinks that there are parallel universes. Some of which is called M theory, which is like multiverse theory, and then string theory, which is what his title is. He's a string theorist, but also like an M theorist. They're kind of, he does both. But he contributed to like the string theory equation. And what string theory is that the idea that the entire universe is made up of tiny vibrating strings, similar to like a violin or a guitar where you pluck it and everything is just all connected. They've never directly observed a string because of how small it is. It's the smallest but smallest point that you can get to if you had a microscope that was that powerful. They used to think that atoms were the smallest object, but atoms can now be broken up into smaller particles. And although strings are not particles, it's the smallest division that any object can get into. And this isn't in this book, but I remember reading somewhere that they compared the size of one string to the size of a tree compared to the size of the universe. So if you can think of how big the universe is, one string would be the size of a tree on Earth, which is astronomically, the difference in size is astronomical. So because it's so small, they've never directly observed it, but through a lot of the science in this book, they reason why that might be a possibility. And there is a lot of science in this book, but they try to put it in terms that people who don't study science can understand, or they try to explain it in a layman's term as best that they can, which he does pretty well. Some of it still goes over my head, but it was fun to go along with. And there was never really a time when I couldn't really figure out and I was completely lost. So that was nice. But it is a science book, so you have to include, obviously you have to include science, how equations came about, the important figures of how we got to where we are today. He talks about Einstein and, other characters that contributed to famous equations that we use every day, which is kind of what a lot of these books do. Science books is they kind of have to give you a foundation of where they came from, so that whatever science they do throw at you, you can reference it and be like, well, that's where we got it from. So towards the beginning of the book, there's a lot of that like history, where we came from type of stuff. So and which is pretty common in other books. So you'll kind of, if you pick up a book that's similar to this, you'll kind of see like Neil deGrasse Tyson's book, Astrophysics for People in a Hurry. That's another good one. Kind of has similar, backgrounds and histories of where we came from. So that's part 1. Part 2 is the multiverse. Chapter 5, dimensional portals and time travel. I'm absolutely fascinated by time travel, and its paradoxes. So he talks about how it might be possible if you were to, somehow create a wormhole, which is basically connecting this point of space to this point of space without actually having to traverse the distance. So if you were to say that you wanted to, grab a piece of paper here. If you wanted to travel from, I don't have anything that's not written on. If you wanted to travel from this point in space to this point in space, from here to here, but you didn't actually want to travel this whole distance, a wormhole would basically fold space and connect those 2 points, and then you would basically go right through the paper, and then you'd open the wormhole up again, and then you would appear at the point that you wanted to get at, but without actually having to travel all that distance. So sorry it took me so long to show that. But time travel, some of it could have to do with wormholes, where if you could connect space and kind of go around in a loop, and eventually you could get back to a point back in space before you start or before you actually left. One of the other methods of time travel that I wasn't aware of that sounded cool to me that I learned about in this book is called the Misner Effect, which is, I might be missing a few details, but if you imagine if you're in a room where if you walked through this wall, you would appear on the other side of the wall, so behind you. And each time you went through the wall, you gained like a 2 mile per hour boost because the wall would be closing in. So if you went through this wall, you came out the other side of the wall, but then since it's closing in at 2 miles an hour, you'd be gaining that 2 miles an hour each time you went through. So eventually you'd get to a point where the room is like this, and you would keep going through faster and faster each time. And eventually you could reach the speed of light and surpass it. And theoretically, if you went faster than the speed of light, then you could be going backwards in time, because time stops at the speed of light. So to an observer, if we wanted to watch light travel, 1 light year, it would take 1 year to get there, since we're watching it. But for the light particle, the photon, as soon as a photon comes into existence, it's already at its destination, because time does not pass for light. Which is why the closer that you get to the speed of light, the slower time goes for you. So if you could reach light speed, time would not pass at all for you. And if you could surpass that somehow, then you might be able to go backwards in time. Accelerating to the speed of light, though, is problematic because based on Einstein's equation, E equals mc squared, the more energy that you get, which is the E, the more mass that you need and the more mass that you attain. So if you try to accelerate to the speed of light, or if you attain that, then you basically need an infinite amount of mass, which so far isn't possible, because we have a hard time contemplating what infinite is, but it's just an unattainable amount of mass that you would need in order to accelerate and get to the speed of light or close to the speed of light. Although existing faster than light is not against the laws of physics or nature. Space itself, for example, exists and is accelerating faster than the speed of light, which is why, light never reaches the end of the universe, because universe itself is expanding faster and light can never reach up to it. So there's nothing wrong with something existing faster than light, which brings up a theoretical particle called a tachyon, which might exist faster than light. They don't really have any evidence for it, but they use that as a placeholder of, well, if a particle existed faster than light, then if time stops at light speed, then maybe something existing faster than light might go backwards in time, might exist backwards through time. So there's really no way of how do you observe a particle that's moving backwards in time? So they don't know how to do that yet, but it's nice to think about. Some paradoxes of time travel that are discussed include the grandfather paradox, which is a really common one. And it basically describes the idea that if I go back in time to kill my grandfather before I was born, what would happen to me? Would I disappear out of existence, or would I create an alternate universe or alternate timeline where I still exist, but my grandparents never did? But the paradox part comes in when you try to line it all up, linearly. So if I go back in time to kill my grandfather before I was born, or before my parents were born, and I kill him, then that means that I was never born in the first place. So I can't go back in time to try to kill him. So if I can't go back in time to try to kill him, that means that he still exists. Grows up, has my parents, and then my parents have me, and then I go back in time to try to kill him. But if I exist, if I was born and I went back in time to kill him, then that means that I would have never been born in the first place. So it's this cyclical idea of, one trying to make one come before the other doesn't really make sense. Another time travel paradox that is discussed is the Bootstrap Paradox, or at least that exists. And that's basically where if you try to go back in time to prevent something from happening, then you end up causing what you tried to prevent. So if you went back in time and tried to prevent someone from dying, the act of you going back in time may have been the cause of why they died in the first place, whatever those circumstances might be. So it's this that event has no origin; it just keeps happening forever and forever. So that's chapter 5. Chapter 6, parallel quantum universes. There's a lot of science that goes into this one, but Michio Kaku describes if there are, they describe the universe as being 11 dimensions total. We live in 3 dimensions. 4th dimension would be time that we experience, because you never say, I'll meet you here. You always say, I'll meet you here at this time, or you'll never say, meet me at 3:00. Well, where? There's always a time and place that come together where you never meet someone without a time and you never meet someone without a place. They're always together. That's why they call it space-time. But they think that the universe has 11 dimensions, and that if those higher dimensions, like 5 through 11, do exist, then they would have to be so small and so fractionally away from us, millimeters away from us, even though we can't see it. And I can't really explain that. He can explain it better, but that's what he says. But these higher dimensions are in directions that we can't comprehend. Carl Sagan explained it as what our 3 dimensions would look like to 2 dimensions. So if you can imagine a world called Flatland, as he called it, if you can imagine a world that was completely flat, where it only had length and width, so it can only go this direction, and this being can only go this direction or this direction. If you can imagine that world, and then a 3-dimensional being passed in front of them. So now we have height, so we pass this way, even though they can only go this way and this way. We can go this way and pass in front of them. So to a flatlander, they're completely flat, and they would only see, as I'm passing in front, like if this is me with my legs here, if they're looking at me from this direction and they see me pass through their line of sight, they would only see cross sections of me as I'm traveling down. So if I were to if my, if my computer mouse here, if this will let me show it, if my computer mouse is an object that's passing in front of them, then you would see it as cross sections. So whatever the shape of this mouse is, you would see little lines like this getting bigger like that as it passed through. But as I went like this, you would just see some weird shape all of a sudden appear. So now a two-dimensional being doesn't understand height. They don't understand this direction, even though it makes perfect sense to us. We can't really imagine being only this way and only this way. So now if you extrapolate that into higher dimensions, we can only see length, width, and height, but any higher dimension is any other direction other than those. So even if we try to look, well, what about this way? What about that way? What about this way? What about that way? That's still all within 3 dimensions for us. So you'd have to imagine a direction in which it's not this way, or that way, which is really hard to do because that doesn't make sense to us. The same way that 3 dimensions don't make sense to a 2-dimensional being because that's just not how they exist. So with these 11 dimensions, he's saying that the universe would have to be, the other 11 dimensions would have to be so close to us that, in a different direction that we couldn't, that would be hard for us to measure it. Chapter 7 is M theory, the mother of all strings. So that's, going along with multiverse existing, because so far within our universe, there isn't only just one of something. There's not just one species of animal. There's not one tree. There's not one planet. There's not one star. There's not one galaxy. There's billions and trillions of stars and galaxies. So if you keep going with that idea, why couldn't there not be only one universe? Why can't there be more? So why couldn't we exist in a multiverse that of other universes that may be different, laws of physics, different ages, different sizes. So that's something to think about. Chapter 8, a designer universe. Our conditions on Earth seem to be perfect, or seem to be, finely tuned, as a lot of people might say. We're the right distance from the sun. Other things, like we're not too close to the sun, or else we would burn up. We're not too far away, or else we'd be too cold. So different. They calculated this probability of, of what the chances of us being here and existing, and those odds are astronomical. But the fact is, we're here, so those odds happened. Whether it was designed or whether it came about by natural means, who knows? Because there's no telling where we could have came from. They're trying to solve that, but you never know. It could be possible that we were created, because even though these odds were astronomical, that doesn't mean that our universe was the first universe. If you've got, I don't know, it's like a really big number to like the 31st power or 32nd power or something like that of these odds. There's no reason to believe why ours either was the only universe, where if a universe was before us and then it died and came back into a singularity again, and then another one exploded, so like an oscillating universe where it keeps happening over and over again, each one of those universes has a chance of having different laws of physics and different, properties. So if the universe is infinite, or if there's a multiverse with an infinite number of universes, then eventually those probabilities will come true and will happen. But there's nobody in those universes to say, hey, our universe sucks. Why can't we have that one over there? Because ours has the right conditions, theirs doesn't. So if you don't have the right conditions, then you can't be there to say, hey, our universe sucks, if that makes any sense. Chapter 9, Searching for Echoes from the 11th Dimension. A lot of science that I can't explain, but goes along with the 11 dimension thing. And then part 3, Escape into Hyperspace. Chapter 10, The End of Everything. How is the universe going to die? Is it going to die by fire, or not fire, but like heat, by expanding so far out, by heat where it, collapses into itself and everything gets hot again? Is it going to die by being cold where everything just keeps expanding, forever, and things get so far apart that the total temperature of the universe drops to, so cold that nothing can move around? Because the universe is cooling down. It has cooled down already. When it first came into existence, it was unfathomably hot. And, 380,000 years, it cooled down enough to where light particles could be formed, and that's where the cosmic microwave background comes from. Escaping the universe. Can we survive the death of our own universe? Who knows? That might require to become so advanced in technology that we can bypass a universe, which, who knows? That might be possible. He talks about different civilization types of varying, intelligence or power consumption. Like ours is, there's like a type 1, 2, and 3, and each different type, can harness he considers us like a type 0, so we're not really that far. We still rely on, resources on our own planet. We can harness the power of the sun, but not the whole sun yet. So I think of a type 1 is harvesting your sun's power. Type 2 is harvesting, the galaxy's power, an entire galaxy. And then type 3 is I forget. It goes up in varying degrees of how much power that you can harness. So can we survive the universe? Who knows? But this book actually led me into a science fiction novel that he mentions in here called Tau Zero by Paul Anderson. And I have a book review of that if you want to check that out, where there's a spaceship that does survive the death of the universe. And you can watch that if you want. I'll put the link to the video in this description. Chapter 12, Beyond the Multiverse. Don't really have any comments on that. But, going off of what I said earlier, there's not just one of something. Maybe there's not just one universe. Maybe there's not just one multiverse, whatever that means. Because if there's a bunch of universes, soap bubbles, within this massive space called the multiverse, maybe there's a bunch of multiverses. What would that even look like? Even more soap bubbles? Who knows? So overall, I really loved this book. I crave learning about space, time travel, anything sciencey really. But, love the planets and black holes and galaxies and just learning everything about it and, dimensions. And, so this book is perfect for that. I love all the universe TV shows and how the universe works and stuff like that. So if you love, learning about this, I think this will be right up your alley. Michio Kaku explains it in a way that is very understandable, not all the time, because some things are just so advanced that it's, probably unless you're a scientist, you can't fully grasp it, but the idea is there, and that is very attainable to listen to and to read. I found out about this book by actually shopping for other books. There's a used bookstore that I go to that's like 4 stories. It's huge. And walking through the aisles, I was actually looking for science fiction, I think. And as I was looking through the aisles, I just happened to pass by this one. It looked awesome. And I mean, it caught my eye. The cover is really cool. It's pretty colorful. And I had already known about Michio Kaku just from the TV shows and interviews that I come across. And, picked it up, and for book lovers, it just felt good. You know what I mean? If you love buying books, it felt right. So, and just going through it, the text is cool and it's kind of worn out. And I like worn out books. I like new books too. But sometimes worn out books, it's like you can see the age and the use that it got previously. So I'm like, well, that's pretty cool for me. So, to recap, like those things, it's easy to understand. If you're not, you can still pick it up, but I think it's more geared towards people who are prone to like learning about, sciencey things anyway. Like I would never pick up like a Western because I'm just not interested in reading like Western books. So if you're not particularly interested in like space or science, generally we pick up books that we are prone to like. But if you're curious about things like that, or you don't know where to start, this is a perfect spot to start. So I'd have to give it a 5 out of 5. As I say that, it's funny because like I just said, we're prone to read the books that we like. So in a way, hopefully I don't give all these books that I'm going to be reviewing on this channel 5 out of 5, but in a way I hope I give them all 5 out of 5 because I don't really want to read a book that I'm not going to like, but just to get some diversity in there. You're not going to like every book, but who knows? So 5 out of 5, pick it up if you want. Also, if you want to check out Tau Zero, which is a science fiction novel that is mentioned in this book, you can check out my book review and discussion of that one on my channel, or I'll just include the link there. So thanks for watching. Subscribe, like, dislike if you want. Thanks for watching, and I'll see you on the next one.